low-cost carbon capture with just water and pressure. A new method known as pressure-induced carbon capture, PIC, is offering a low-tech twist on a high-stakes challenge, reducing the cost and complexity of capturing carbon dioxide from industrial emissions. Developed by researchers at Texas A&M University in partnership with Excel Thermic Enterprises, the PIC system skips over the expensive solvents and high-temperature regeneration used in traditional amine-based capture technologies. Instead, it applies a basic physical principle. CO2 dissolves in water under pressure and escapes when that pressure drops. In effect, PIC mimics the release of fizz from a soda bottle, but at industrial scale. The result is a system that can reportedly capture up to 99% of carbon dioxide emissions using only water, standard equipment, and pressure differentials. The same water can be recirculated, further minimizing operating costs and maintenance overhead. From exhaust to storage, how PIC works. Rather than relying on chemical reactions, PIC uses a sequence of physical steps to isolate and collect carbon dioxide. Emissions from sources like power plants, cement kilns, or hydrogen production are first cooled and compressed. This compressed gas enters an absorption unit where it meets a downward flow of cold water inside a packed column designed for maximum gas-liquid interaction. As the CO2 dissolves into the water, the treated exhaust exits with minimal carbon content. The now CO2-rich water is then sent through a series of lower-pressure tanks where the gas gradually bubbles out and is collected for compression and either permanent storage or industrial reuse. In some configurations, the process can be enhanced with small amounts of lime to improve CO2 removal, especially from combustion air, pushing capture rates to 100% and enabling net negative emissions when paired with biomass. What makes this model noteworthy is its simplicity. Unlike solvent-based systems that degrade over time, require chemical handling, and involve complex thermal regeneration steps, PIC leans on well-understood physical laws and modular hardware. That translates to faster permitting, easier retrofits, and lower long-term operational risk. A cost curve shift for heavy industry. While carbon capture has long been seen as essential to decarbonizing hard-to-abate sectors, it remains constrained by high costs. The standard amine-based systems typically capture about 90% of CO2 at a cost between $50 and $100 per metric ton. In contrast, early economic models for PIC suggest capture and compression at around $26 per ton. Even with added lime for full carbon removal, costs stay below $28 per ton on average, making it a compelling option for industries confronting emissions mandates and carbon pricing. By focusing on pressure and water instead of heat and chemicals, PIC offers a scalable, infrastructure-compatible bridge for legacy assets in power, cement, and manufacturing. It won't replace the broader need for clean energy, but it could buy time and reduce emissions while the transition unfolds.